Hello everyone. Today we will be discussing RUPSA, an equilateral triangle of October 2015 long challenge. In this problem we were given n, thus a length of equilateral triangle side, and we were supposed to alter one of the sides to uh, an even number and check if the height of the isosceles triangle formed is an integer. In this problem the number of test cases are very huge, so for this tells us is that we are supposed to pre-compute our answer. For this question we have to understand some properties of isosceles triangle. For isosceles triangle, the median and altitude are same, that is this line h of length h is dividing a into two parts, and also it is a perpendicular, and it is also dividing the entire triangle into two parts. So consider one of the sub-triangles. By Pythagoras theorem we can write h square equal to c square plus n square, where n is your b, h square is this, and c square is a by 2, that is a by 2 square plus h square equal to b square. For this in our editorial we are given that if we have to check if a number can be represented in the form of two perfect squares, sum of two perfect squares, then we have to check if the number is divisible by a prime of the form 4k plus 1, where k is an integer number. Also one point to note here is that here we are checking if a number has a prime factor of the form 4k plus 1. So for checking n square we can check only n as n square. If n is having a prime factor of form 4k plus 1, then n square would also be having a factor 4k plus 1. These are some of the Pythagorean triples. Here phi square can be represented in the form of 3 square plus 4 square, 13 square can be represented as 5 square plus 12 square. Here we notice that we haven't taken 6, 8, 10. Also 10 square can be represented as 6 square plus 8 square, but this one is just a multiple of 3, 4, 5, so we haven't taken that triple. And all these triplets can, if we see carefully, the last number can be is of the form 4k plus 1, 5, 13, 17, 25, all of them are in the form of 4k plus 1. Here is our code. We are declaring a boolean array of size max. Here max is defined as 5 into 10 raised to 6 plus 5, that is we are given the maximum limit of n. Inside the main we are pre-computing our values, so this part is checking all the numbers up to root of max, that is from I equal to 2 to less than max. We are checking all of them. Inside them we are checking j equal to 1 to less than I. So what we are doing is actually computing the sum, that is for the first case I equal to 2 and j equal to 1, so 2 into 2 plus 1 into 1, that is 4 plus 1, that is 5. So and 5 is less than max, so answer of 5 is true, that is 5 can be represented in the form of two perfect squares. Similarly all the numbers can be found out, and this part is not necessary. This is just printing the first 100 values, so after the first computations. So here we can see 5. For 5 we have written 1, then 10 we have written 1 because 10 can be represented as 3 square plus 1 square. Then 13 can be represented as 3 square plus 2 square. Similarly, all the values are calculated. After calculating up to root of, here we have calculated up to root of max. So for the next numbers we have to perform another for loop. Inside this we are making all the multiples of a number true. If a number is true, then all its multiples are true. That is, if let's say I equal to 5, so answer of 5 is true, right? So all multiples of 5 are true. We are performing this by another for loop. After computing this, we have all the values pre-computed. Then we are scanning the number of test cases inside inside this while loop. We are scanning n, that is n is the side of equilateral triangle, and just we are checking if answer of n is true. If yes, then we are printing yes, else no.